Hi, in this video I am going to discuss tabulation methods. The tabulation method is also known as Quine McClusky method. It is a specific step-by-step procedure to obtain a simplified standard form of expression for a given function. Generally, the karnaugh map is very useful and convenient tool for simplification of Boolean functions as long as the variables does not exceed 6. But if the number of variables increases, the visualization and the selection of patterns of adjacent cells in the karnaugh map becomes complicated and difficult. So, to overcome this difficulty, we are using tabulation method. The main procedure to obtain the simplified expression by tabulation method is first we need to find out the prime implicants. Then from the set of prime implicants, we have to find out the essential prime implicants. These essential prime implicants are obtained by prime implication chart. What is implicant? A single product term is called an implicant. This is one implicant and this is another implicant. The product term, the variables can be either in complemented or uncomplemented form. Then prime implicant. Prime implicant is a product term and it cannot be combined with another term to eliminate a variable. A implicant that is covered by only one possibility to reduce the expression is called essential prime implicants. The prime implicants are obtained by the following procedure. The first step is each minterm of the function is expressed by its binary representation. The second step is the minterms are arranged according to increasing index. Now the third step is each of the minterm is compared with the minterms of the higher index. If two minterms are differed by only one variable, that variable is replaced by a dash to form the new term with one less number of literals. A line is drawn in when all the minterms of one set is compared with all the minterms of a higher index. The same process is repeated for all the groups of minterms. Then a new list is obtained after the first stage of elimination is completed. At the next stage of elimination, two terms from the new list with a dash of the same position and also it's differed by only one variable or compare, and again another new term is formed with a less number of literals. This process to be continued until no new match is possible. Then all the terms that remain unchecked, that is where is no matches found during the process, are considered to be the prime implicants. Prime implicant chart. After obtaining the prime implicants, a chart or table is prepared where rows are represented by the prime implicants and the columns are represented by the minterms of the function. Then crosses are placed in each row to show the composition of the minterms that makes the prime implicants. Then a completed prime implicant is to be inspected for the columns containing only a single cross. Prime implicants that covers the minterm with a single cross are called the essential prime implicants. Now let's discuss tabulation method with this example. F is equal to 1, 4, 6, 7, 8, 9, 10, 11 and 15. These are the minterms. We are going to minimize using Quine McClusky method. The first step is arrange all the minterms in a list of increasing order. so that the groups of terms contain the same number of ones. So first we are listing all the minterms in the binary form. We are arranging our minterms in the increasing order. So 1, 4, 6, 7, 8, 9, 10, 11, 15. This is the minterm representations. And here our binary representations are A, B, C, D. In the 1, the equivalent binary representation is 0, 0, 1, 4, 0, 1, 0, 0, 6, 0, 1, 1, 0, 7, 0, 1, 1, 1, 8, 1, 0, 0, 0, 9, 1, 0, 0, 1, 10, 1, 0, 1, 0, 11 is 1, 0, 1, 1, 15 is 1, 1, 1, 1. Now, next step is we are grouping into number of ones. For example, minterm 1 and minterm 4 having number of ones in the binary representation is 1. So, we are grouping these two into group 1. Next, we are going to group two number of ones in the binary representation. So 6 have two ones, and 9 is have two ones, and 10 also have two ones. So we are grouping based on these combinations. The next grouping is 3 ones. The 3 ones are 11. Next grouping is 4 ones. The 4 ones are 15. So the step 2 is we are arranging the minterms according to their number of ones. So for group 1, the number of ones is 1. So we are having the minterms are 1, 4, 8. These three combinations we have number of 1 is 1, 1. Next, group 2. In this group 2, we are grouping the number of ones as 2. So 6 have 2 ones, 9 is having 2 ones, 10 is having 2 ones. Next, we are grouping into 3 ones are present in the combinations. So 7 is having 3 1 and 11 is having 3 ones. The next grouping is 4 times ones. So 15 have 4 ones. So we are grouping under group 4 here. So it's represented here. So group 0 contains no ones, and group 1 contains only those minterms 1, 4, 8. Group 2 contains 6, 9, 10. Group 3 contains 7, 11. Group 4 contains 15. Then step 3. Now we are going to compare each binary number with every term in the adjacent next higher order category, and if they differ only one position, then put a check mark and copy the term in the next column with dash in the position that they differed. For example, compare minterm 1 from group 1 with each of the minterms in group 2. Then minterm 1 in group 1 and minterm 9 in group 2 or differ only one variable. So here we see group 1 is coming under group 1 and 9 is coming under group 2. So we are going to compare the combination present in group 1 and group 2. So I am starting from minterm 1. Here we this 1 and 9 in group 2 or differ by single bit change. That is only the single bit change is A. Here 0, here 1. So the change in bit we are represented as dash. So the next combination, the reduced combination from this minterm 1, 9, we are writing as the changing terms are represented as dash, and the remaining 3 terms are 0, 0, 1. We are writing as it is. Similarly, we are comparing all the combinations from group 1 and group 2. Then once group 1 and group 2 is finished, we will compare with group 2 and group 3. Once these combinations are finished, then we will compare with group 3 and 4. Similarly, all the groups has to compare with the other groups. So here the comparison in group 1 and 2, we are comparing group 1 minterm 1 with group 2 with the minterms which one is having single bit change. So group 1 minterm 1 and 9 is differ by single bit change. So we are writing dash in the A and Z, B, C, D we are writing as it is. Now 1 and 9 is combined. Combined and we are writing here. So these two combinations are checked here. Similarly, we are writing the we are finding the single bit change from group 1 and group 2 for all the combinations. Once 1 and 9 is over, the next single bit change is we can compare with 4. 4 is we can compare with 4 and 1 0. Okay, 4 and 6 we can compare. 4 and 6, the change in bit is C. So we can write it as 0 1 dash 0. Similarly, we are comparing all the combination with the next higher order group. Once group 1 and 2, all the combinations are over, we are going to compare with 2 and 3. That means 6 and 7, 6 and 11, next 9 and 7 and 9 and 11, next 10 and 7 and 10 and 11. Once these all the combinations are over, we will compare with group 3 and 4. Now M7 7 and 15, next 11 and 15. So the checked combination, the what are the combinations are coming under here, we will put the check mark here. So sometimes some combinations are unchecked here. That combinations or prime implicants, we have to write it in the final expressions directly. So this is the final checked representation. Here all the combinations are combined with other combinations. So we put check marks. So here the combinations 1 9, 4 6, 8 9, 8 10. This is the comparison between group 1 and 2. Next group 2 and 3, the comparisons are 6 7, 9 11, 10 11. So, then this is the comparison between group 3 and 4. 7 15 and 11 15. So the differing bit is we are representing as dash. Remaining bits we are writing as it is. So this is the representation for single bit change. Now we have three groups, group 1, group 2, group 3. So first we are going to compare with group 1 and 2, then 2 and 3. So we will start with the group 1 and 2 first. So here first we can start with the dash symbol. So wherever the dash is there, based on that. So 8 9 and 10 11 have same position in dash, and the remaining 3 bits it's differ by C bit. So here C we are putting as dash, and already this dash is from the previous table, and now we are putting a dash here for the single bit change. So here we are writing the combination 8 9 10 11. So that combination 8 9 and 10 11 is put the check mark. Similarly, for the remaining combinations, 8 10 and 9 11 is checked again. So here the single bit change is C, so we are putting the dash. This dash is from the previous table. So we are writing 10 dash dash. So only now we are putting the check mark in 9 11. So only 4 combinations are checked. So we are writing only tick mark in this 4 combinations. The remaining combinations we are writing as it is. These remaining combinations we are going to write in the prime implicant charts. Now all the unticked minterms from the first table to last table are considered to be prime implicants. Now these prime implicants are used to form a prime implicant chart. Now let's see how we are going to make the prime implicant chart. This is the prime implicant chart. The terms are represented here, the PI terms, that is prime implicant terms, and here the min terms, and here our all min terms, all our min terms are represented in the rows here, and here our PI terms, that is the prime implicant terms, are represented in the column. Now here our all min terms 1, 4, 6, 7, 8, 9, 10, 11, 15 is written here. Now the min terms, these 5 min terms are coming from the table 3, and this is from table 4, and the prime implicant chart is table 5. So here we are writing the min terms here. The corresponding product term is represented here. So now these min terms are 1, 9. So we are putting cross in 1 and 9. Here this min term is 4, 6. Now we are writing 4 and 6 here. Here this min term is 6, 7. So we are writing 6 and 7. And here we are writing 7, 15. So 7 written here and 15 written here. And 11 and 15 we are writing 11 and 15. And from table 4, 8, 9, 10, 11, and the another combination also same 8, 9, 10, 11 only. So we are writing one combinations here. So 8, 9, 10, 11 is represented. Now we have to check row wise. Each row we have to check which one is having a single check mark. So this column, this row has single check mark. So we are putting tick here, and the corresponding min terms also we need to put a check mark. And the next single check is here. The corresponding min terms is this one. We are putting check mark here. The next single check mark in the row is this one. So the equivalent min terms are this one. So we are putting check mark here. Now the next single cross mark is this cell. So we are putting the equivalent tick in the min terms. So now this tick mark in the min terms are considered as a essential prime implicants. That means only one possibility to group this min terms. So these 3 combinations are coming under the prime implicants chart. So now the remaining terms 6, 7, 7, 15, 11, 15 is there. From these 3 combinations, we need to take which one is coming for the final combinations. So based on this essential prime implicants, we have written the expression is, for this combination the expression is B bar C bar D, and the second 4, 6 the combinations are A bar B D, and the 8, 9, 10, 11 the expression is A B bar. So these 3 are essential prime implicants. So the left min terms are 6, 7, 7, 15 and 11, 15. We will see how we can simplify these 3 min terms. So in the previous prime implicant chart itself we got it, the essential prime implicants. The essential prime implicants are 1, 9, 4, 6 and 8, 9, 10, 11. So from the now the left min term 6, 7, 7, 15 and 11, 15. From these 3 combinations, we are going to find out which one is coming for the simplified expressions. So first we will analyze 6, 7. 6 is already covered with this combination. So this is grouped with this combinations. Next, this 11 is already grouped with this combinations. So the left min terms are 7 from this combination and 15 from this combination. So we are considering only 7, 15 expression for the final simplified expression. So 715 is equal to BCD. So once again the reason is from 6-7 expression, 6 is already grouped with this combination. So only 7 min term is left here. Similarly, in this combination, 11 is grouped with this combination already. So the min term left is 15. So the uncovered ones are 7 and 15. So the 7 and 15 is present this combination itself. So we are taking 7 and 15 combination only for the final expression for the simplified expressions. So once the essential prime implicants are found, we will get the simplified expressions again by checking the min terms grouping with the other cells. So this way we can reduce the min terms, reduce the logical expressions for any number of variables by tabulation method in easiest way. In this question, we are going to simplify the expressions using tabulation method. Here the don't care combination 2, 3 also included. Now this don't care combinations we are using to simplify further. In K-map also we are using the don't care combination to simplify the logical expressions. The same way this don't care combination will help to simplify the output expressions. So the first step is list all the min terms according to the binary representation. So our min terms, we are included our don't care term also here 2 and 13. So we are writing in the increasing order and the equivalent binary representations. So the second step is we are going to group based on the number of ones. So this is the step 2. We are arranging the min terms according to their number of ones. So the group 1 min terms are 1 to 8. We are grouping according to number of ones. Here single ones are there. And group 2 we are arranging according to 2 number of ones. So 3, 5 and 9 is present. And group 3 number of ones is present. And group 4 5 ones are present. Now the next table we are comparing our group 1 and 2. So we are comparing group 1 and 2 first. Then the comparison combinations we are putting the check mark here. So first we are comparing group 1 and 2. So the combinations are 1, 3 and the differing variable is C. So we are putting dash here. The next combination is 1, 5. The differing variable is B. So we are putting the dash here. Next combination is 1, 9. So the differing variable is this one A. Next is 2, 3 combinations. So the differing variable is D. Next combination under group 1 is 8, 9. The differing variable is D. So the next we are grouping group 2 and 3. So group 2 and 3 we are comparing 3, 11, 3, 13. The next comparison is 5, 11 and 5, 13. Next 9, 11 and 9, 13. So we are we got the combination is 3, 11, 5, 13, 9, 13. Next we are comparing group 3 and 4. So the combinations are 11, 15 and 13, 15. So both combinations we obtain here and the variables differ here B and here C. So here all the combinations are compared with the other combinations. So all combinations are checked. If any combinations are unchecked, some cases some combinations are unchecked here. These combinations we need to write it in the prime implicant chart to simplify the expressions further. So this table formation is over. Now in this table we have three groups, group 1, group 2 and group 3. Now we are comparing group 1 with group 2 and group 2 with group 3. So we are first going to compare with combination 1 3 with 311 and 1 3 with 513 and 1 3 with 913. Next we will compare 1 5 with 311, 1 5 with 5 3, 1 5 with 9 3. Next 1 9 with 311, 1 9 with 513 and 1 9 with 913. Next 2 3 with 311, 2 3 with 513, 2 3 with 913. Next 8 9 with 311, 8 9 with 513, 8 9 with 913. So the combination we obtained is 1 9 5 13 and 1 5 9 13. The differing variables are A and B. And also 9 13. Okay, this is coming under group 2 and 3. Now comparing with group 2 and 3, 311 with 11 15, 311 with 13 15. Next 513 with 11 15 and 513 with 13 15. Next 913 with 11 15 and 913 with 13 15. So here we obtain the combinations are 9 13 11 15. And here 1 9 311 also we got it from group 1 and 2. So the differing variables are 1. Here the differing variables are B, C. For this combination the differing variables are A and C. So here only 1 2 3 4 5 6 combinations are checked. The remaining combinations 1 3 2 3 8 9 and 13 15 is coming under prime implicant chart. We will write these unchecked terms into the prime implicant chart. This is the prime implicant chart. Now we are obtaining the prime implicant terms from table 3 and 4. So the 3 and 4 table min terms we are represented here. The equivalent expressions are written here, and the min terms along with the don't care combinations are written here. So here we are writing for the min terms. So 1 9 5 13, the check mark 1 5 9 13. Similarly 1 3 here and 9 13 11 15 we are written here, and 2 3 here and 13 15 here, 8 9 here and 1 9 3 11 is written here. So now we will check the single check mark. The single check mark is obtained here. The equivalent expression is this one, and next single check mark is here. The equivalent expression is C bar D. So these two expressions are coming under essential prime implicants. Now the uncovered min terms are 1 3 9 13 11 15, 2 3 13 15 and 1 9 3 11. From these 5 combinations we are going to get the simplified expression. So now our essential prime implicant terms are found. That's the red color combinations. Now we will see what are the remaining prime implicants will come under the final expressions to simplify the output. So here we will see 1 3 9 13 11 14. Here 4 min terms are grouped. Now we will see here 1 3 combination. 1 3 is coming under this combinations. These two are 4 cell grouping. So 4 cell we need to give preference to 4 cell grouping first. So 1 3 is grouped within this combination. So we will put this combination will not coming under the final expressions. So I put a cross mark here. Then next 2 3. 2 3, the 2 isn't don't kata. So only the min term is 3. The 3 is already grouped here. So this combination also will not come under the final expression. The next combination is 13 15. This 13 is don't care, and also 15 is included with this combination. So this combination we are taking for the final expressions. Same way this combination also we are taking for the final expression. So the final expressions B bar D and AD is included, and these three combinations are eliminated. That means the 1 3 is eliminated, 2 3 is eliminated, 13 15 is eliminated, because 13 15 is covered with this combination, and 2 is the don't care, 3 is grouped with this combination, and 1 3 1 is already grouped with this combination, and 3 is grouped with this combination. So these three combinations are eliminated, that is 1 3 2 3 13 15, and only this 9 13 11 15 and 1 9 3 11 combination is considered for the final expression. So this is the final simplified expressions with the don't care combinations. This is another example. It's a 4 variable questions. So first we are writing the expression in equivalent binary representation. Now here we are grouping according to number of ones. So this here we grouped number of ones combination, here number of 2 ones combination, here it's 3 ones combination, and here 4 ones combinations. So the table 2 is represented for cells grouped according to number of ones. Now this is table 3. In this table 3 we are comparing group 1 and 2 and 2 and 3 and 3 and 4. The same procedure we used. So here 1 3 combination we obtained. So we put check mark 1 and 3. Next 1 9, 2 3, 2 10, 8 9, 8 10. So all the combinations are checked here. So these are the possible combination we will obtain from table 2. So once table 3 is obtained, we are going to get the 4 cell combinations. Now we are grouping this group 1 and group 2, next group 2 with group 3. So 4 cell combinations we will obtain, and the differing variables we are representing with the dash. Here it's a 2-bit variable change, and this is the single bit variable change. Here one variable is eliminated, here 2 variables are eliminated. So the combinations are 1 3 9 11, 2 3 10 11, 8 9 10 11, and 3 7 11 15, 10 11, 14 15. Here table 2 and table 3 all the combinations are checked. So for the prime implicant table, only these 5 combinations will come. This is the prime implicant chart. We are finding the prime implicants from previous 2 tables. Now the prime implicants terms are written here, and the equivalent min terms are represented as cross mark. Now we will see the single check mark. Now here the single check mark, so we are writing check mark here, and this one single check mark, so we are writing check mark here, and here single check mark, so we are writing here, and here single check mark, so here also we are writing, and here single check mark, so here we are writing. So all these 5 combinations are essential prime implicants. So this is the final expression. The essential prime implicant combinations are written here. In this question, the don't care 6 8 is given. So we are following the same procedure for writing the binary numbers in equivalent higher order increasing order combinations. Then we are arranging into number of ones in table 2. This is table 2, this is table 3, and this is table 4. Now in this table 1 we are writing the decimal in the increasing order along with don't cares. The don't cares are 6 and 8. Now we are grouping into number of ones. Here this is number of 1 is 1, here number of 1 is 2, here number of 1 is 3. Now we are getting the table 3 by comparing this group 1 and group 2. So here the combination we obtained is 1 3, 1 5, 1 9, 4 5, 4 6, 8 9, and 8 10. So here all the combinations are checked. Now group 2 and 3 combinations we will obtain as 311, 911, 1011. The differing bits are represented as dash. So now single literal is eliminated in this table 3. Now in this table 4, 2 variables are eliminated. And in this table 4, we will compare this group 1 and group 2. So 1, 3 is compared with 311, 911 and 1011. Similarly, 1, 5 is compared with 311, 911, 1011. So we will obtain the combinations are 1, 3, 9, 11. The differing bits are A and C. Next 8, 9, 10, 11. The differing bits are C, D. Now these unchecked combinations 1, 5, 4, 5, 4, 6 will come and will coming under the prime implicant chart. So this is the prime implicant chart. So the prime implicant chart, the minterms are 1, 5. 1, 5 is written here. Next 4, 5. Next 4, 6. In that we are not writing the don't care terms. It's optional only. Next 4. The 4 we are written. 6 is don't care. So we are not written in the output expressions. Then here 1, 3, 9, 11. Next 8, 9, 10, 11. 8 is don't care. Now here the single check mark we will see. This one is having single check mark and this combination have single check mark. So these two will coming under the final expressions. These two are called essential prime implicants. Now in that remaining combinations 1, 5, 4, 5, 4, 6, we will see which one is coming under the final reduced expressions. So here 6 is don't care. So we are not considering this combination. So this left midterm 4 is coming here. And this one is already grouped with this combinations. So here 5 is ungrouped. So our ungrouped terms are 4 and 5. So we are taking 4 and 5 in the final expressions. So this is the final output expression for the given question. This is the 5 variable question. So first we are writing according to the input decimals in the increasing order format. Next table we are writing in the binary representation and we are grouping according to number of ones. This is here number of 1 is 0. So this is called group 0. This is number of 1 is 1, group 1. Number of 1 is 2 here, group 2. Number of 1s are 3, group 3. Number of 1s are 4, group 4. So first we are comparing group 0 with group 1. Then group 1 with group 2. Then group 2 with group 3 and group 3 with group 4. So first combination for group 0 and group 1 is 0 to 0, 16. The differing variable is D here, here A. Next we are comparing group 1 with group 2. The combinations we will obtain as 2, 3, 2, 18, 16, 18, 16, 14. Next group 2 with group 3. The combination we will obtain is 3, 7, 3, 11, 5, 7, 5, 13, 9, 11, 18, 26, 24, 26, 24, 28. Next combination is group 3 with group 4. We will obtain the combination with single bit changes 14, 30, 26, 30, 28, 30. So this is the group 3 format. Here all the combinations are checked. Next table 4 is 4 cell combinations. Now we are comparing group 1 with group 2, then group 2 with group 3, then group 3 with group 4. Now the 0, 2 is combined with all this combination, compared with all this combination. Then 0, 16 is compared with all this combination. Next 2, 3 is compared with all this combination and 2, 18 is compared with all this combination and 16, 18 is compared with all this combination and 16, 24 is compared with all this combination. Next this group 3 and group 4 is compared. The final combination we will obtain as 0 to 16, 18. Two variables are eliminated here. 16, 18, 24, 26. 24, 26, 28, 30, 11. These are the three combinations we are obtaining, and the unchecked combinations are prime implicants combination, that is 2, 3, 3, 7, 3, 11, 5, 7, 5, 13, 9, 13, 8, and 14, 13. These are the prime implicant combinations. We have to write it in the prime implicant chart to simplify the expressions. This is the prime implicant charts. The prime implicants are written here and the corresponding minterms are written here, and the minterms are represented in the rows, and we are putting the cross mark in each rows. So for example, 0 to 16, 18, we are written the check marks here, 0 to 16, 18, the next one 16, 18, 24, 26, next 24, 26, 28, 20, 28, 30. So we are writing the check mark for each rows. Then these are the min terms we obtained from the table 3 and 4. So here first we will see the single check mark. Here we have single check mark. The equivalent expression is this one. Next single check mark. The equivalent expression is here. Next single check mark, the equivalent expression is this one. Next single check mark, the equivalent expression is this one. So these 5 combinations are coming under the essential prime implicants. So the essential prime implicant expressions are written here. The uncovered combinations 513, 511, then 311, 37, 23, and 16, 18, 24, 26. We will see in the next chart how we can simplify it further. This is the reduced to prime implicant chart. So here the red check marks are essential prime implicants, and the remaining combinations are uncovered min terms. So now we will see how we can simplify these expressions further. Now see 16, 18 is already grouped with this essential prime implicant, and 24, 26 is covered with this combination. So this combination is eliminated in the final combinations because all 4 combinations are grouped with these 2 combinations. Next coming under 2, 3. In this 2, 3, 2 is grouped with these combinations. Then 3 is covered with this combination. So this combination also eliminated. Then coming under this combinations, 13 is grouped with this combination, only 5 is left. And here in this combination 3, 7, 3 is grouped with 3 is covered with 3 is covered with this combination, and 7 is uncovered. So the uncovered combinations are 5 and 7. So we are grouping only these combinations, and we are taking this combination for the final expressions. So these combination expressions are A bar, B bar, C. So the final reduced expression for 5 variable tabulation method is this one. Thank you.